Hi, this is going to be a lecture on basic AWS architecture. AWS consists of the AWS cloud region. So this is the top level entity within AWS. So the AWS cloud region is just a cluster of data centers that are located in a particular place across the globe. So currently AWS has so many locations or so many regions that span across the globe. A majority of them are in the US, Asia, and in Europe. Within the cloud region is an entity called as the availability zone. An availability zone is basically a distinct location that resides within an AWS region, and these are engineered to be isolated from each other so that if there is a particular failure, that failure is just isolated within that availability zone. So this provides a level of high availability within your particular cloud region. So within these availability zones, you can create your VPCs. So a VPC is a container within which all your resources would reside. So this includes your EC2 instances, your RDS instances. So this is basically the container which would contain most of the resources that you would create in AWS. And the important thing to remember is that it spans across availability zones and it has an RFC 1918 CIDR range. So the CIDR range that I have shown here is 10.0.0/16. A VPC also contains an internet gateway. An internet gateway makes it possible for the resources within the VPC to connect with the outside world. A VPC is comprised of subnets. A subnet is located within one availability zone, and here you can see that I have created two subnets, and these subnets have a CIDR range which is the subset of the VPC CIDR range. The subnet to the left has a CIDR of 00/24 and the one to the right has a CIDR of 1024. These subnets can be distinguished by the routes that they have. So a private subnet is one which has a route that allows packets to travel only to the subnets within that particular VPC. So here the route table has just one entry, and this makes it possible for traffic to flow only to the subnets within that particular VPC. Whereas if your subnet is connected to the internet gateway, then it has a separate route in the route table, and this route table entry is basically just a connection to the internet gateway. So here you can see that the other route in the route table is 0000/0 and it connects it to the internet gateway. So what that means is that any resource that wants to connect to the outside world goes through that particular route and via the internet gateway and to the outside internet. From a security perspective, the subnet contains or is enclosed by a NACL. A NACL is called a network access control list, and its basic aim is to protect traffic both inbound as well as outbound. So a NACL is basically stateless. So what that means is that you have to allow both inbound as well as outbound traffic to flow through it separately. This is how a NACL looks like. So here what I'm trying to do is I'm trying to deny ICMP pings into the particular resources that reside within the subnet. So how the rules are deciphered is based on the rule number. So it traverses through the rule number from the lowest to the highest. So once it reaches rule number 90, it sees that there is a deny for ICMP pings across all ranges and across all port ranges. So once the NACL sees that there is a deny associated with a particular protocol and a particular type, then it goes no further and it basically doesn't allow ICMP pings to be triggered within that particular subnet. Same rules also have to apply for outbound rules as well. So the important thing to remember is that rules are triggered based on the rule number from the lowest to the highest, and the rules are either deny or allow. Here is an incorrect way of applying the same rule as shown in the previous slide. So here the rule number is 110, and the rule 100 allows basically all traffic to go through. So the NACL will first go to rule number 100 and it will allow all the ICMP pings, and it will go no further and it will not go to rule number 110. So you have to be very careful while associating rules with its corresponding rule numbers. And within these subnets are resources that you would create. So these would include EC2 machines or even RDS databases. So there is another layer of protection across these resources, and they're called as a security group. A security group has no deny and has only allow, and it is also a stateful protocol. I mean a stateful protocol. So what that means is if you allow an SSH or if you allow an ICMP, then the outbound also is explicitly allowed. So here the rules that I have shown you is basically it allows only SSH and ICMP pings. The SSH is allowed only from port 22, whereas the ICMP pings are allowed from all ports and from all sources. So all the other kind of protocols would, including the HTTP protocols, would be denied because it's not explicitly mentioned in the security groups. So now let's look at how the route works. So if you have a resource within the public subnet which wants to go outside the subnet and outside the VPC to the internet, so that happens based on the route table that I have shown you. Now because the destination 0000/0 connects it to the internet gateway, so that makes, like I said before, that makes this a public subnet, and that makes it possible for any of the resources within the public subnet to connect to the internet. And it also, and the other route, that is the 10.0.0.0/16 local, makes it possible for it to connect to all the other resources within that particular VPC. Whereas if you look at the private subnet has access to the other subnets within the VPC, but it does not have access to connect to the internet because there is no connectivity, or should I say there is no route to the internet gateway in that particular route table within the private subnet. So this was a basic illustration on how all the AWS resources looks like. In my next lecture, I'll show you how practically these resources look like, and I will give you a demo on the same. I hope this was a useful lecture. Please subscribe to my channel. Thank you.